All right. Hello, everybody. If you can hear me in chat, that would be nice if you can mention it. The plan for today is like to continue the load balancer stream series. The agenda for today is doing more strategies, and maybe we can implement health checks as well. All right. So last time, I guess we so I added a bigger, a more realistic README. After the last one. Hello T3 Schno. Jen Show. I have no idea how to read that. How's that going? Right. So I created this offline, and that's the only thing I added from last time, and it shouldn't matter that much. Okay. So let's what I want you to implement today is so let's copy the example. So I have the normal example that config.yaml to example config. It's Tensho. All right, Tensho it is. So config weighted. So one nice strategy is like that you can have the same service, right? But your replicas can have other information. So your replicas can have a name, and then they can have a weight associated with them. So they can have like a URL and then some metadata associated with the replica. And instead of doing round robin here, I would like to do a weighted round robin. And the idea is like, what if we have servers that can handle loads in multiple ways? Like I have server 1, and server 1 has 32 vCPUs and 16 gigs of RAM. And the same server, and we have some server 2, which has only 1 gigabyte of RAM and 1 vCPU. So the amount of load that server 2 and server 1 can handle is pretty much different. So if we try and balance the load in a simple round robin manner, because round robin by definition kind of supposes that all your servers are the same, or at least can handle the load in the same way. So this strategy kind of try to balance that out when you have multiple types of servers. And I guess this strategy kind of works nicely. So it's similar to a round robin, where all the weights are 1, right? So yeah, and I guess like to. So let's go to YAML validator. I want to check the syntax here to make sure I get the syntax correctly. All right, so weighted round robin. And what I want to add here is maybe a name. It's like URL, right? And so the URL would be this. And the replicas would be something like, okay, so I have a URL, and then so we have the URL, then we have some metadata associated with it, right? And the metadata itself can be something along the lines of So let's remove this from here. I don't think this is required. All right. Metadata would be like weight is, let's say this one is 10. And we'll do the same thing here. You want me to zoom on the browser? Sure. I hope this is better. Let's make it full screen for now. If this is still too small, you can say it in chat. That would make it bigger. So let's say the only metadata that I have for now is the weight, right? So let's try and do the same here. Say we're all again. Right, and then metadata again. So let's replicate this, right? Right, this is 82, and this is the, let's say this, the weight for this is 5. And let's add a comment here saying that we suppose this example shows to a load balancing strategy that will work if the servers don't have if the servers don't have a same ability to handle load, right? Let's validate this maybe. Okay, so in this context, line 11. Okay. I find it's easier to think in YAML in JSON than have YAML later. So let me copy this. I have services. Let's zoom in for you guys. So let's say name, service 1, strategy is something of round robin, matcher, replicas. Let's have the first replica, right? And the first replica would be this. So it has a URL, which is HTTP. Let's do full addresses. Metadata. Wait. Let's add in another one. And this is 2. Right. And the weight for this is, I don't know, 10. This is 5. or 4. Now let's pick this up. Okay, this is valid YAML according to... Although it's a little bit weird how this is left. Okay, YAML validator. I want to choose another one to make sure. Online YAML validator. Sure. YAML is valid. Right. Okay. So this feels like the thing that I want to match. All right. So let's do this. So I want to match this and be able to do this. So how can we implement this? So our data model should change here, right? Forgot to copy the comment. Oh, nah, never mind. Shows how to configure load balancing for when replicas don't offer the same load balancing capability. And I would say that usually this is a result of difference in compute power. Right. So let's take this. We have a loader test. So let me give this to this round robin loader. Config with weighted round robin. So we want this strategy to be weighted round robin. The URLs would be the same. So this is localhost 8081. So let's put in localhost because it doesn't matter what we put here. Localhost. Right. Metadata. Should be fixed here as well. So let's run this test. So this will fail. Because we can't unmarshal some stuff. Right? Which does, yeah, the weighted round robin. Alright. So let's do, let's verify that this works at least. Let's make this work. So we have a config. Let's go to the loader. Or at least the config something. Right. Our servers have a strategy, a name. A name, a match, a strategy, and a bunch of replicas. Now the replicas are their own object, right? So let's make a replica. We gave it an URL. A string, which is in YAML as URL. What did we add also? We did a URL, a string, which is the URL, which is a string, and then we had the metadata. And the metadata is a map from string to string. YAML. And hopefully it would be, so these are the replicas. But this will make, alright, so this will make some of our strategies fail, maybe. I'm not sure what's gonna fail, so let's go test. Right, so alright, so service replicas, and we want the URL. Okay. Not into motivational speeches. Okay, this still fails. Because cannot use replica type something as type string. That's my configuration. My strategy have services, and the service has names. Strategy and have a bunch of replicas. All right, so we have a matcher replicas. Now the replicas are an array, right? The same bug. Metadata? Could be. We have URL, then we have metadata. And we have the weight as, yeah, a bunch of string to string. Okay, so we have an errors in the first one. Right. So here it broke. Okay, so I want to remove the metadata section. Okay, so this is progress. Right, so now it's a weighted round robin, and then I guess I have a strategy test, right? So I only want to round robin here. And the previous test kind of said that this is a test service, right? So it's 22. Yeah, the strategy I didn't mention any. So I can say strategy is round robin. Okay, so we have some API matcher. All right. It's gonna get fixed. So config.services.0, the matcher is API v1, right? Let's copy the same test over. And let's paste this one, and then let's call it test. Weighted disload config, weighted round robin. Right, so here is weighted round robin. The strategy should be like this, and the default strategy is here. Now we have additional stuff. We have metadata, and then we have weight is equal to 10. So what's the strategy? It's still the same, but the strategy now here is weighted round robin. Right. And okay, we found it a tab character that violates indentation. Sure. Let's fix it. So indentation here is spaces. Okay, line 8. We still have so it's 1, 2, 3, 4, 5, 6, 7, 8. Really? I can't see any tab characters. No, it says line 8. Oh, come on. 11. Okay, so this is... Alright. Now we're back to a passing state. Now we should fix something in main. Yeah. So for each replica, I want the replica's URL for this to work. Right. Now, I kind of want to make sure that our initial setup still works. So let's remove this. I guess I don't need it anymore. So let's run, go, run, may not go. Now we want to deconfigure, no such file. Oh, that's examples, right? Right. Yeah. So the config file. No waits. Right. So let's start off the other servers. Let's start one at some port and then the other one at the other port. Right, and then let's run a curl. Okay, it's still working. Okay. Great. This should be automated somehow. I kind of don't like doing it, but let's do the simplest thing that can work first. Okay. So we didn't break the first strategy. Now it's time to actually write the new strategy. So let's commit first. Seems like a stream 3. Add. What did we add? Yeah, change the config model. Right. Now what we want is like to run in a weighted fashion. Now the only strategy that we have is like we have a round robin strategy. We have a round robin. This is a nice typo. Oh. All right, all right. This is a C++ strategy for doing this, but yeah, sure. Now, what do we know about servers? So, like to write the next. So let's say we have a weighted. It needs to know some stuff about each one of the servers, right? So it's next, and taking a bunch of servers. Give a domain server. I'll give an error. We'll return null for now. And now for each one of those round robin strategies, it needs to have a map for URL, I guess, and current count, right? And I guess think it needs a mutex. Sync.mutex. It's a read route mutex, right? Now we need to, I guess, to change, because we don't know the counts for each server. What's the count for each server? Because the server only knows its URL and its and the proxy. We need to add something else to make the changes reflect. Right, so let's do a actually, I don't want to change this. So let's find a way to do it without actually changing. Can we create it somehow with the mapping? Because we need some information that kind of says that server X can handle X requests in a row. I actually don't know. So what I don't want to is I guess we'll have some metadata attached to the server at some point. So let's just... It could be anything. Let's say it's a string. Metadata. A bunch of functions for a server. Our default. Get meta. Our default. Let's give it the key. Let's give it the key and the default value, right? And this will give me a value, right? Which is a string. Gets meta or default, returns the value associated with the given key in the metadata, or returns the default. So let's say value in OK and s.metadata of key. If not OK, just return default. Otherwise, return v. Right? And we want we'll want one to return an int. Get meta or default int. So the key is a string and the default is an int. And this should return an int maybe. Returns the value associated with the given key in the metadata or returns the default. Returns the int value would be more appropriate. So now what we should do is like we say get meta or default of value of key and the default value would be always 1, right? So if we said that the current value is not 1, we kind of take into assumption that this will be used by something else, by the weighted round robin strategy, which I didn't want to couple them. So we can clean this up later, I guess. So just get the value here, and then is there a str conv, I guess? A to I, yeah, that's the one. So we convert v into a value. So this is like the int, and this would be the error. And then if error is not null, this can happen if this has a value and while the key is not an integer. So in this case, we should return the default value that we wanted, which is 1. Otherwise, return a. Yeah, the default value here is 1. The primary use case for this function is the weighted round robin, which defaults to 1. Actually, I'm giving the default to begin with. I guess this is cleaner. Now I don't have to care whether it's 1 or not. It's on the caller to determine this. Right. Any questions in chat about what I'm currently doing? I'm not sure if anybody's confused by with what I'm currently doing. Okay, chat is quiet. All right. So let's start to use this thing here. Yeah, so the servers we would keep track for. So let's do like r.mu. This would be just a mutex, I guess. I don't really need to make the difference between reads and writes. All right, so let's do r.mu.lock. And let's defer r.mu.unlock. Right? And of course I need to keep a current, right? Oh, right. Let's take let's do this. We suppose that the server list is not gonna change behind the scenes, right? So let's just assume that that we are stateful, and then we won't have to change the server list at first. And in that case, we know for sure that we can make a counter array. So the array would be like something like the count would be an int array, and then the current would be the int, right? And I guess this, since this the and I guess since this is note making the assumption that the server list coming through the next function won't change. Yeah. So because if the server list changed while we were just doing the, so this can be called from multiple Go routines and would be fine. But the moment this list changes, this list gonna break. So changing the server list would cause this strategy to break. To break. Oh, not wrote properly. So here we're gonna make if our account is, so if it's this is first time using this, the way oven. If it's the first time, we need to allocate for the count. So let's say air.count equals make servers right, and then the current would be 0, right? Maybe. Yeah, that's how it's 0. And now okay, So now we are at current and we have some servers. Now we need to check if our count of current, of r.current is equal to 0. Servers dot, or at least servers of r.cur capacity is servers dot r.cur get meta int our owner. We have the weight and 1. It's either has something or it has 0. So if it's set capacity, right, it means that we can still handle still one request, and in this case would increment the count, right? Right, and then we would return the r.cur. So the servers, we would keep all the same servers, right? Otherwise, server is at its limit. So moving on to the next one would be equals r.cur. This is safe because we're talking a full-on mutex at the first of the function. So we know that we have exclusive access over the current variable in the function. Mod the servers. So we'll take the next server and return it. But before doing this, we need to reset the count for the current one. Right? Reset the current one and move on to the next server. So this looks relatively straightforward, but we wouldn't know until we test, right? So let's register. So since we're doing this, which server did we pick? So we picked servers r.cur. Right. Similar to the round robin. The only difference is that it takes server compute power into consideration. The compute power of a server is given as an integer. It represents the fraction of requests that one can handle the one server over another. Around robin strategy is equivalent to a weighted with all weights equal 1, right? So yeah, so let's register this. I guess we have a function for this. So k weighted, k weighted, I guess. Weighted round robin is a balancing strategy that returns a. So let's create a mutex var mu equals mu sync.mutex, and let's return a weighted round robin while with the mu equals mu. Copy lock. Why? Okay, this is better. All right. Let's test it out. So let's look at the configuration first. So we have a weighted round robin now as the configuration. The match. What's the difference between this one and this one? All right, so it's the same thing, only this one we need to look that server 1 should take 10 requests and server 2 should take only 5. And then it goes on. So let's, but this time it's config weighted, right? Let's try this. Sorry. Now let's do a curl. So the strategy picked 1. Right, we picked 81. Oh, it picked strategy 882. Huh. So let's look at the logs. I'm kind of confused by the log result now. So we first got this, and then we picked 8081, and then we picked 8081 again, and then picked 8082. We picked 8082 again, and then 8082 again. So 3 requests. All right. Okay, so first let's make sure that the correct configuration is being loaded, right? Received requests, forwarding requests to. So let's see which strategy got picked up. Strategy with name not found. Falling back to around right? And then here we have name. So we picked weighted round robin. Oh, there shouldn't be a warning. All right. So we get 8081, 8081, 8082. Okay, so it's 8081, 8081, 8081, 8082, 8082. Oh, right. I guess I know why. We never... Yeah. We never set the... Ah, that's stupid. So what happens here is that at startup we set this configuration list and then we create the servers, but the servers need more stuff. They need metadata. And the metadata is on the... It's breaking up for some reason. Services. Huh. There was an error finding the package. All right, so we have servers. Every server has some metadata. All right. The replicas have metadata, right? Yeah, I need this to be... Okay, so let's try now again. So 8081, 8081, 8081, 881, 1, 1, 1, 1, 1, 1, 2. Alright, so it's applied it for 8 times. And then for another 5 times, and then it got 881. Okay. Cool. Seems like the weighted round robin strategy actually works. Let's look if there are any more cleanup that can be done. This should be properly unit tested later. I'm just making something that can work and we can clean up later. Right, I guess this kind of shows a bit more intent. Add. Right. So this kind of finishes up the weighted round robin strategy, right? Let's see. So I wanted to implement health checks. Right. So servers can go down, and we don't want to forward to requests to servers that already gone down. So if a service is going, so if a server goes down, we want a way to make it to detect that and then not forward requests to it, even if it's the next server to be used. How can we implement this? Let's see. Let me start from here. So we create, once we start, before we start serving, we have this, what Fairly has this server list, which is a map from servers from mappings to a server list. Right? Now we want to watch for the health of every matcher. Right? So every server list, so the server list has a bunch of servers. Right. So each server kind of can be in two states, either healthy or unhealthy. So we can either attach this information at the server level and then have a flag on it that marks it healthy or not. So we can have a process that actually runs indefinitely. And every, I don't know, every minute, it can loop over the server list servers. And it can know whether if a server is down or not, right? So we can add this information here. So we can say that a server can be alive, right? Let's say alive. And this function should be, I guess, since it's gonna be changed from another, right? Since it's gonna be changed from another possible coroutine, we should probably guard it with a mutex. So let's have read-write mutex around it. So these are fixed at creation time, but these are not. This is also, I guess, fixed. This can change. So we should have maybe add a function to update the state of liveness. Set alive. Set liveness. Right. And it should return its old state, right? So we can do s dot mu dot rlog wlog. Oh yeah, lock. Right. You can defer s dot mu not unlock. Unlock, right? Since this is gonna change the, so let's see, the old value equals s alive, and then s dot alive equals value, and then return old. Right. And then we can say func server is alive. We would probably have the same code, only this time no need to take a full lock, we'll just take a read lock. Alive. Liveness state of the server. Okay. Now let's go back. And let's add a health checker type, right? Maybe. Let's make their package health. Go. Let's have a type health checker. I don't think we'd need anything special in the health checker, but we'll see. Yeah, I'll probably need the server list, right? Um, it- need checker. So maybe domain. So let's take the configuration. So the configuration should have another parameter, which is like the health period, maybe. Yeah, so we want to, this period would be in milliseconds, maybe. And then let's have a func start on the right. The config should have some other field that kind of supplies the period. We'll try to ignore it for now. And we'll just return a health checker. Period is 1. No errors. So once we start, I'll just time the ticker. So give it a duration. Right, so this will give us a ticker. Right. And it would be hc dot period seconds. How about this? Oh, I can't have that. Let's keep it at that. Maybe that'll work. So ticker. I forgot how to use this. Let's block these for now. Let's go to 4 maybe. Chrome. Golang ticker. Right. Examples of new. So the function was new ticker. Right. So you take the ticker for some range and then. Right, and then you can range over it indefinitely. Okay, looks good. Really? Should I read maybe? Oh. Oh, I see. So this could leak? Yeah, so we have a new ticker, and then we can defer the ticker.stop. Oh, I see. So this can leak. Sure. So we had, I guess, ticker.stop. No, and then we can read ticker.c. Right. Actually, I'm never gonna use this. Why is it complaining? Oh no. Okay. So now we should implement the check health. for a given server. Right? Should report if a server So how to do this? So we can take the host and the port and we'll suppose, okay, we will consider a server to be healthy if we can open a TCP connection to the host port of the server within reasonable time frame. So let's dial the timeout. Is there are multiple overloads for this? Can we ignore the network part? Server.url.host. Time that Why am I getting the app engine on? Wow. Import resolution is weird. Server URL.host. Return, otherwise connection dot. I don't really care about the connection. As long as this is successful. So we want to look at, so here before we return, we should set the server to old equals server dot set liveness to false, right? If old is not false, transition from transitioning server from live to from healthy, at least healthy to unhealthy state. Actually, live to unavailable. Host maybe? So we only want to log if there was some state transition, and this could be like written like if old means there was some transition, otherwise we wouldn't say anything. And all would be like server dot set liveness. It's true. So if not old, transition in server from unavailable to live state. And this would be an info. Right. So whenever we're gonna do a ticker, we'll try and mark servers as available or not. So we'll do so we should be able to connect within 5 seconds. And for the period here, I want... So let me ignore the period here. I wanted to at first make it configurable, but I don't really care now. Let me just make it time that second. So every 2 seconds, let's say every 5 seconds. When I be able to do this. So for a server, issue that servers. Let's make this double the amount of time it's gonna take to do this. Right. This should be private to this module only. I don't think it's required to know about this. Oh, wait. Right. Right now the configuration is kind of not unused, but that's okay. If you want to configure this period, right. Now, where should we put this health checker? Right, so we should probably put it at the so the service right. For the servers, sure. Now, Fairly can take care of this now. When we create the server list, we can say health, not new health. New checker, we have config maybe. We have servers. Okay, what's the configuration here? Oh, do we have a domain config? We can pass in now. For the time being, we don't use it. Oh, yeah. Now it's a checker. Okay. So what's the start point of Fairly? So once we create a new Fairly, we should probably for each key value, we don't care about the key matcher. We only care about this server list in range of server map. Right, so now we can start all the health checks. Oh, wow. Okay. I want to log the start. Um, Alright. Okay, we started the health checks. Now let's see if it picks up that the servers aren't alive. Right. So we can connect to the server, we cannot connect to the server. Neither servers is available. Right. So let's start off one of the servers. See if it picks up that server 2 is actually alive now. Okay, so it can't pick that both of them are dead. Oh, I guess it's because of the network. Zoom in a bit. For some reason, it can't pick it up. We need to look at the documentation for net, Golang net style with timeout. So what's style with timeout? Dial timer or okay, so there are no examples here. Right. So I guess what we I guess we need maybe the TCP. Not that. So let's look if we can pick up that only one of the servers is not. All right, so it started the servers from unavailable to live state. Now 8082 is alive. Now 8081 can't work because like we still reporting that it's not able to respond to because it's not succeeding the health checks. So let's bring up 8081, shall we? 8081. Now it should mark that it's transitioning from some state to another state. If we're lucky, yes. So we transitioned from 8082 to 80 from unavailable to live for that server. You know, seems like it's working. Warn F. Right, now we will start all servers at not an alive state unless they succeed in the first life check. So for this to make sense and to work, we need that our strategies implement this as well. So what we should do is like the next is not the current. Right. So if the next round robin one is not available, I'm not sure what we should do. Okay, so servers should. So here, what we would like is like if servers of. So if the picked is alive. So if it's not alive, right? And in that case, we want to do some things. Now, this gets this is gonna make this a little bit more complicated because we can't do just the atomic add right now, because the atomic add guaranteed that we will get the next server, and that's about it. We will have an additional value. But now if both values called next at the same time, like we can skip one of the alive servers. So we'll have to have a defer mu.unlock. Now we can remove this. Let's mark current as int. And let's do scene is equal to 0 and next equals RDA current, right? And then for scene is smaller than len of servers. Right. So now I don't think I need this. Just care about how much I've seen, and if picked is alive, good. We can return picked. We can break. So if picked is alive, we can break. Otherwise, we just continue checking. And if at some point... So if seen equals to len of servers, all servers are down. And we might wanna... We will probably return an error here. So all servers are down. All of the end servers. None. Available. Right, now we have, I guess we have round robin that can work with this. The only thing that we would need is, for us, after every one of them, we can increment as that current equals current plus 1 mod len of servers. Okay. So I guess if we try this, but this time we run with the config. So we picked round robin this time. Let's kill one of the servers. So now I guess we could still. So all of them are in live state, right? So we can curl. We pick servers. Okay, so I'm only picking up the 8081, which is not good. But let's kill one of the servers. This is not good. Is there a bug? Probably. Yeah, okay. So if we pick something up, we should probably just skip. Right. So let's see if it can pick if I kill one of the servers. So if we do, now it wouldn't work because all the servers are down. Okay. Now we get 81, 82, 81, 82, 81, 82, and that works fine. Now let's kill one of the servers. So we transitioned from live to unavailable. And now it's... Oh, we're getting all servers are down. But that's not correct, right? Okay, so for some reason all servers are down, while only one of them is down. Okay, so there is miscount? Not sure, maybe. So the current starts at 0 and the mutex starts... So we lock, unlock, we find the defined one, and we start at 0, look at the length of the servers. So scene. Alright, so I need the number of... Okay, so let's see. So all of them are running. They should start. Both of them should start. Okay. Let's run. Let's curl. Everything is working. Now let's kill one of them. So the health should pick it up in 10 seconds. All right. Now we only get routes to 80, 81. Now let's get this back up. Now it's live, and now it's load balancing again correctly. Cool. Now this is the intended behavior. One thing that's, I guess, left to do to finish up, at least for today, is like once we... So the next error here, we don't handle it. I guess we do. We do handle it. If we can't find the next server, we would probably have this. And we'll get the status internal. So that we handle, I guess. Okay, I thought we don't handle this. Cool. Right. So I guess off stream I'll do the same thing for later on tomorrow, maybe tomorrow morning. I'm feeling pretty tired, so tomorrow morning probably I will add the same thing for the weighted round robin. I'll do the same strategy for like checking with whether the server is alive or not. So what's the... So the strategy here would be like whether we have capacity or not, right? It doesn't matter if the server is not available. So even if we have this, the server needs to be available. So servers of r.cur is available, is alive, and this. We can't have one without the other, right? So it should be alive and it should have this. Otherwise, we can't return it. Otherwise, we will move to the next server. Now, the plan here is like we suppose that this should solve the problem while it shouldn't, right? So scene is 0 again, and for scene is smaller than len of servers, right? we should probably do this. And so we get the capacity for the current server, and if it's alive and something, now if it's not alive, we will never pick it, right? We'll just reset it. We want to, right? So the ideal here would be like to have some sort of state transition. So let's say we got this, and then we have something that is picked, right? So let's do var domain server as the picked. Let's say picked equals to servers of odd occur, right? Now if picked is alive, if picked is not alive, we'll have to, we'll have to do a similar thing that we do here. What did hit? So if it's alive, we want to break. Otherwise, we want to increment the scene, right? So if picked is alive, oh. So if it's alive, we want to check the count here. Right. So if it's not alive, we want to increment the scene, so the number of servers that we saw that were not alive, right? And we need to continue. And we want this to happen, I guess. So here we know the server is alive. And we want this to happen before, right? So if the server is alive, we want to check the capacity. If the capacity is wrong, is okay. We want to return the picked, right? Okay, so we pick the server, otherwise it's below capacity. So if picked equals nil, or scene equals len of servers, we wanna keep it consistent, so let's do something like this. All servers are down, check servers. Those are the available. So okay, so let's recap. So whenever we see a server that is not alive, we increment the scene value. And want to continue. So here, continue would mean like doing this as well. Yes. Next. Otherwise, if this is cool, this is okay. We can continue like and just check normally, however we did with the weighted round robin, is that one server could be good if it's small in capacity. Otherwise, we can just reset the capacity for it and move on. Right. So let's try and weight it. All right. So we started the health checker. This would give me like all servers down because the check for the servers is failing for some reason. Okay, so all server, now the servers are up. So the first 3 or 6 requests probably should come from 8081, right? Now we start 8082, right? Now let's scale 8082. And let the health check server kind of pick it up. Let's see if it can pick up on the change. It picked up on the change, and we'll keep forward into 8081. Oh. That is weird, because we should never. Okay, so this is a bug. Why are we able to do this? So if the pict is not alive, so if it's not alive, we can increment the scene, and the count would be incremented, and we continue to the next available server. Otherwise, we increment the count for the capacity. So I'll just, yeah, so the count for the capacity is this, and we return the pick value with a null. Now the count would be reset. Is there anything different here? So here we only increment so the server is dead. Move on to the next one. And it should be done at first. now we pick this current server. We'll get the weight of the server. The capacity here doesn't matter. The capacity here at least doesn't matter. Strategy pick pattern. Oh, it didn't pick that. We never picked this. This is the only way we picked. We can return from within. Actually, this is never reachable. So I don't think we should ever reach here. Because if we look at all the servers, and they're not, and we never reached this. Right. Let's try it again, see if we can reproduce it. So let's start this before. So both of them are available. Let's run this. Okay, it's working as. So let's scale one of them. Let it pick it up. Okay. Yeah, we're only getting 882. Did we ever get a request to 882? Oh yeah, that's the health checker. Okay. If we get this back now. Carol. Okay, now we can get 8082, 8881. Okay. It seems like it's broken pretty good. I guess why I thought it wasn't working because there was a missing log line. Right. That got left. Stream 3. Add health checks. Right. So I guess this concludes stream 3. We managed to add one weighted round robin strategy, and we added a health check, and we implemented it in such a way that it integrates with the available strategies for now. Next time we'll be able to maybe try do config reloading or maybe add more unit tests. As always, like, contributions are welcome to the project, and if no one has any questions, we can finish the Twitch stream here. All right. Thank you, everybody. See you in the next one.